Welcome to day one of the 60 Days Microservices Interview Mastery Series. Here is a real production scenario. Your payment service suddenly goes down. Should the entire e-commerce application go down? The answer is no. In this video, we will learn how microservices isolate failures using the circuit breaker pattern. Imagine an e-commerce system with order, payment, inventory, and notification services. A customer places an order, but the payment service becomes unavailable. A senior engineer must prevent this failure from spreading to other services. The goal is to keep the system responsive while handling the payment failure safely. Here is the interview question: if one microservice fails, should the entire application fail? A strong answer is no. A resilient microservices architecture isolates failures. We use techniques such as timeouts, circuit breakers, carefully designed retries, asynchronous communication, fallbacks, and monitoring to prevent cascading failures. Now look at the bad design. The order service makes a synchronous call to the payment service. If payment becomes slow or unavailable, requests can wait, threads can remain busy, and traffic can pile up. Latency increases and the failure may spread. One unhealthy service can eventually create a system-wide outage. The better approach is to design for failure. Use synchronous calls only when immediate results are required, and use asynchronous messaging where it fits the business flow. A message broker such as Kafka can reduce tight coupling between services. Combine this with timeouts, circuit breakers, and monitoring to isolate failures. A circuit breaker has three main states: closed, open, and half open. In closed state, requests flow normally. After failures cross a configured threshold, the circuit opens and blocks calls. After a wait period, it enters half open and allows limited test calls. If the service recovers, the circuit closes again. In Spring Boot, Resilience 4J can implement the circuit breaker pattern. We protect the payment call and define a fallback strategy for failures. The important point is that a fallback should represent a deliberate business decision. Do not simply hide exceptions. Design what the system should safely do when payment is unavailable. Here is the production flow. Payment starts failing. The circuit breaker detects repeated failures and opens. Further calls fail fast instead of repeatedly hitting the unhealthy service. A safe fallback or recovery workflow can run. After the service recovers, the circuit tests it in half-open state and can return to normal operation. A senior-level interview answer is this: no, one microservice failure should not bring down the entire application. I would use timeouts, circuit breakers, appropriate retries, asynchronous communication where suitable, safe fallbacks, and monitoring. I would also consider idempotency and reconciliation for payment workflows, because payment failures can have ambiguous outcomes. Let's summarize day 1. Circuit breaker protects microservices from cascading failures by failing fast and allowing recovery. Remember the three states: closed, open, and half open. Configure it carefully, combine it with timeouts and monitoring, and test failure scenarios. Tomorrow, we will explore another real-world microservices interview scenario.